Thanks. My name is Chris Gelino. I'm the archive scientist for the Keck Observatory archive, and I want to thank the organizers for allowing me this opportunity to talk to you about some of the new services and data that we have at PiCoA. All right, so some basics. So PiCoA is the NASA-funded collaboration between NEXI, the NASA Exoplanet Science Institute, and the WM Keck Observatory. It contains raw data for all the active and retired instruments. Some of these data go back to the early days of the observatory in 1994. Important right now is the data are transferred at the end of the observing night, so in the morning, from the observatory to NEXI, and they're generally available to the PIs within 24 hours. And those PIs have a proprietary period of 18 months, which they can modify when they submit their proposals. And finally, the archive includes data from all the partners. So all the data that you're hearing about, all the Keck data that you're hearing about today and tomorrow is either in the archive now or will be in the archive once the proprietary periods expire. All right, so currently we have over 56 terabytes of raw data in the archive. The biggest volume instrument that we have is DEIMOS with nearly 19 terabytes of data, which is about double of what the next largest is LRES. So lots of data there. That data comes in many different varieties, flavors. So we have the raw science and calibration data, the calibration data being flats and darks and bias frames. We've got quick look reduced products for a few of these instruments. We also have the TRS, the telemetry recording system for Keck 2, which is a record of the AO actions during NERC2 science observations. Now the AO is on at other times, but we only save it to save space when the science observations are being taken. And as you can see on the left, there's a little movie of the interactive weather plots that are fairly recent additions to our services. It's great to have all the data, but if they're not being used, then that's what's the point? Well, fortunately, we are getting data downloads. I'm showing here 4 different cumulative data download totals for 4 instruments, and in general, most of these have a steady increase as people slowly download the data. But in a lot of cases, we see these large jumps where individuals are downloading massive amounts of data for particular instruments. And usually these are for large projects. So I've noted here the NEXI high-res precision radio velocity project, and then that for high-res, obviously, and then for LRES Kodiak, which reprocessed a lot of the LRES data. And Kodiak is one of our contributed data sets. Currently, we have 8 of these contributed data sets. They're mostly science quality images and spectra, and but the what's in these data sets varies immensely from one data set to the other. We've got 4 more data sets in the prepping stages, and hopefully these will be out soon. I'm not sure when, but soon. And if you do have contributed data that you would like to have us host at the archive, let us know, and we'll get to work on that. All right, some recent improvements. One of the biggest problems that PIs have had in the past is that the data that they download from COA all came in these file names with COA IDs, which did not match up with the file names that they have in the observing logs. We fixed that now. So in addition to the COA IDs, which are unique for each FITS file, we also save the original file names in our metadata tables and results tables. And you can download your data with these original file names, so that you will have a match between what you download from COA and what's in your observing logs. And like I said, this solves a longstanding problem that PIs have had. Related to this, all of the active instruments at Keck now have full metadata in our database tables. What that means is there's nearly every FITS header keyword that's in the files is now a column for these instruments. And if you looked at the FITS headers, there's hundreds of these keywords that are in these files. And so these can be used in constraints when you're doing queries. They can be returned. So, if you want to do a query and, pick out, specific instrument configurations, you can do that with these new database tables with all of these columns. And instead of looking at the FITS file, we have these tables that you can use to search on and actually find the keywords that you want to look at. All right. One of the biggest things that we've been focusing on recently is a Python API to access this data, particularly all those metadata tables that I just mentioned. So the one that we call PiCoA, which is this Python client that offers access to raw, public, and proprietary COA data. Currently, there are only two ways to access proprietary data in COA. One is through the web interface, and then the other one is now through PiCoA. We have support for all the instruments except for LRES, which is in testing, and hopefully it should be released soon. And in PiCoA, we have these methods that you can do simple queries by date, position, object name. But as I mentioned, you can use these these enhanced tables with all the metadata to create these really complex queries and get exactly the data that you want. PIs have access to their proprietary data through this service. And you can also download these science files and associated calibration files. So what we do is we look at the science files, the configurations, and say, all right, these are going to be the flats and darks that are appropriate for you to reduce that science. And we've got lots of examples and notebooks on how to use this service. We have one for each of the instruments. And I'm showing you the page there on the left, and on the right is just a snippet from one of our Jupyter notebooks. So if you're unfamiliar with Python or how to use these notebooks, they're pretty easy to use and install. So, all right. So what drives that PiCoA is a virtual observatory compliant TAP server. TAP is Table Access Protocol. And so we're using the same one. It's built at Nexi, and it is also used at the NASA Exoplanet Archive and the NUIT archives. And so any service, any tool that you have that can use VO compliant TAP servers can use this tool, can use this server. And when we do our testing, we do testing, and we have examples for two Python-based TAP clients, PyVO and TAP Plus. And on the right there, I'm giving you an example of, from a snippet from one of our notebooks on how to use PyVO to access our service. All right. You can also, if you're not into Python, there's other ways that you can use our TAP service to access the data and still do these complex queries. One is a web UI called Ursa Viewer, which is created right here at IPAC. And another is Topcat, which is pretty popular, and it's a separate Java app that you can download. And on our websites, we have examples for using these services as well. So you've got lots of ways that you can access the data now, and there's plenty of examples out there. But you can always ask us if you have more questions. Some of our future plans. So PiCoA's primary future goal is to increase the usefulness and accessibility of the data. There's a few ways that we're going to be doing that, and we're going to continue to focus on PiCoA, and we're going to be adding the LRIS data soon. We're going to be adding reduced data and quick look data downloads. And we're also going to be adding in moving object searches to PiCoA. Right now, the only way that you can do moving object searches is through the web UI. And moving objects, by that I mean like comets and asteroids and planetary bodies. COA also is supporting the Keck, the Observatory's Data Services Initiative. And our sort of roles in that is we need to modernize and enhance the way that users are accessing the data. We'll be serving the science quality reduced data once those are available to us. And one of the biggest changes for us that's, from the ground up is a big change for us is real-time ingestion. I mentioned, early on in this talk that, we currently download all the data. All the data are transferred at the end of the observing night and sent to us. But with real-time ingestion, the raw data and quick look file is going to be transferred immediately after the observation to COA, and it'll be available. So the requirement is that the data are available within 5 minutes of being written out at the observatory. And I'm showing you here some histograms of transfer times for a few instruments. And you can see from the plots that, the transfer times are well under 1 minute, from the time that the file's written to the time that we have it available in the archive. So we're well within that 5 minutes. Yeah, 5 minute requirement. And the bottom, it might be a little hard to see, but one of those instruments there is Demos. And, those are the largest files that we're dealing with right now. And even that, most of the files that are being transferred in under a minute. By 2022, all the instruments will have real-time ingestion for the raw data. So we're looking forward to that. All right. And finally, we're going to be soliciting more community feedback and from our newly formed users group, where I list some of the members right here. And with that, I will say thank you. And if you have any questions, just let us know. Thank you.
Okay. Are there any local questions, Q&A questions?
There's one in the Q&A, which
do you want to read it? And
sure. The question is, can you also download the weather data from COA? Yes. So all the data that we have, even though there's interactive tables, you can download a text file with that same information.
I have a question. Can I ask?
Yes.
How do you, so you said there's like contributed data sets. How does one contribute or a data set? Do they just write you and say, hey, I have some data, or?
That's usually the way that it started. We have a contributed data set policy. So usually what happens is someone sends me an email and I'll send them, here's the list of what we accept. And then usually from there, we just work together on getting the data in the right format. It usually takes some massaging on our end to get the data in a way that's easily accessible for other users. For all of these contributed data sets, we usually have to, create a user interface for the user. So that's usually what takes all the time is, just to prep work on it.
So it seems like you don't just want people handing you every data set that you want or they have, right? You want to, it's some coordination that needs to happen. So.
Yeah, there's a lot of coordination. Yeah, what we don't want is just like raw, that's a tarball of stuff and say, here you go. I mean, that's not useful for anyone else either.
Right.
All right. Let's see.
So does the real-time ingestion include the AO telemetry?
No, that would come later. Those are usually generally pretty large files. So yeah, those probably would not show up within the 5 minutes. But the goal is also to get those down as soon as possible.
Okay, maybe we can do, yeah, one or two more.
Okay. Are there questions there?
In the Q&A. They're in the Q&A. Can you read them?
All right.
Yeah.
Let's see. As a note, all NASA key strategic mission support programs will contribute data sets to PiCoA. That's correct. I forgot one. What was the earliest weather data included? That's a good question. Not sure how early they go. It's usually, I don't think it goes back to 1994, but it's pretty early. And some of the early ones don't have, you can download the data. And so we're relying on other locations to get the weather data. Hi, Chris, what about contributed pipelines for particular instrument? So we, so the pipelines are a bit tricky for us because we at Nexi, we don't run the pipelines to do the reduced data. But what I would suggest is if you have a pipeline for a particular instrument, talk to me, and then we can work out where best to include that pipeline. Because a lot of those are all of these are being processed at the observatory. All right. When you think about the data policies for new instruments, remember that not all important data may be FITS files. And oh, there we go. And data rates are you're used to, like AL telemetry. Our MKID cameras. Okay. Yeah, that's a good thing to point out. All right. Do I have time to answer the other
question? I think we're done. So if you want to take them over to the Slack channel.
Okay. All right. Great.
That'd be great. Thank you so much. Let's thank Chris again. Thanks.